Hello guys, this is group 15, Faith Jimi-oni and myself Salih Çıtak. We are gonna present our final project, which is building a large network for Ontario Tech University with Packet Tracer. Here is our outline, introduction, LAN and CAN, about the project, devices, technologies, requirements, configurations, demo, and conclusion. Introduction. The need for computer networking came from the need to use personal computers for sharing information within an organization in form of messages, sharing files and databases, and so forth. Whether the organization is located in one building or spread over a large campus, the need for networking the computers cannot be overemphasized. A computer network is a group of computer systems and other hardware computing devices connected through communication channels to enable communication between a wide range of users to share resources. The implementation of corporate network scenario is completely network-based. It's a secure network that is mostly used in major organizations and other entities to ensure secure connectivity and exchange of their data and information. The building blocks of computer networks are specialized equipments such as hosts, routers, switches, and access points. A network is created when two or more of these devices are connected to exchange resources via a common convention known as protocols. Now, what is a LAN? Local area network, or LAN, is a type of network that serves a local area and supplies networking capability to a group of computers near each other. A local area network can support as little as 2 or 3 users in the home office or several hundred users in the central office of a company. Homeowners and IT managers set up LANs such that network nodes can share services such as printers or network storage. Campus area network applies to multiple small LANs that are connected across multiple buildings within a small area. Many considerations must be considered to design and construct a well-secured network, such as the topology and location of hosts within the network, the choice of hardware and software technologies, and the careful configuration of each component. To ensure the design is done properly, all requirements necessary for the design are first defined before proceeding to the implementation. Designing and implementation a computer network is a time-consuming, complex, and intricate task in which many divisions of an organization are involved. Usually factors like physical location to the analysis of user website access is taken into consideration during the design and implementation phase. About the project. As a group, we have designed a network for Ontario Tech University for the 3 campuses, Whitby, Downtown Oshawa, and North campuses. This network supports a minimum of 100 computer users, and according to the university's policy, a central server, VLAN, and subnet that handles data with the campuses connected through routers. For the purpose of this project, a LAN network is designed using Cisco Packet Tracer. It's a multitasking network simulation software that can be used to perform and analyze various network activities such as implementation of different topologies, selection of optimum path based on various routing algorithms, creation of appropriate servers, subnetting, and analysis of various network configuration and troubleshooting commands. Networking devices are costly, so it is better to perform first on Packet Tracer to understand the concept and behavior of the network. Devices and technologies. Switch. Switch is used to connect several nodes of network within multiple segments. This device works on the second layer of OSI model. Also, this device transmits data to the recipients except for broadcast traffic to devices with unknown ports. This device eliminates the remaining segments of a network from unintended processing of data and is imperative to network security and performance. Router. Routers are interconnection network devices that send and receive packets between networks. This type of network device is based on layer 3 IP addresses and selects the best path for data transmission in a network. This device, while on the third layer of the OSI model, makes network address-based decisions. Firewall. A firewall is considered as a single device which imposes the access control policy amongst networks. Firewalls, usually a standalone device, is an application software-based or network embedded device. Servers and hosts. The host is a node that interacts in a user program, either as a server, a client, or both. The server is a type of host that provides services to other hosts. Usually a server allows connections from clients who request a service feature. Some of the technologies implemented on this design are access control lists. It's a policy used in filtering routing protocols, permit or deny traffic flows, and to redirect traffic based on the set policy. Also, this policy or rules is processed from top to down until it hits the first match. The access list is then processed only when a condition is met. VLAN, Virtual Local Area Network, is a standard of logically segmenting devices on a network that are physically dispersed. This standard allows network design to be flexible. Similarly, VLANs broadcast domain borders on the second layer of OSI model. These broadcast domains are device groups that receive broadcast frames created by devices in the group. STP, Spanning Tree Protocol. This prevents uninvited loops while creating a redundancy path in a network. Multiple active paths in a network is a major cause of loops. These allow duplication of messages while appearing on both ends of a switch. Similarly, this disrupts the forwarding algorithm on a switch and duplicate messages are sent. This protocol allows a LAN with redundancy to manage the loop period of Ethernet frames. Requirements. Below are some of the functional and user requirements to be met. The three campuses, namely North Oshawa, Downtown Oshawa, and Whitby, should have separate LAN with individual applications. However, these campuses must share data. The design should support email and communication. Design should accommodate the school's intranet. The design should be able to accommodate up to 100 devices. An uninterruptible network is required for user operations. The network implemented should be scalable to endure any future expansions. The LAN should be secured with restricted access. The network should have the capability of filtering what enters and leaves the network. Thank you very much for listening me. Now my friend's fate will continue. Thank you.
Thank you, Sally. So now I'm going to be taking the remaining part of the presentation. First, we're going to be looking at the configurations that we made. First, we have the switch configuration. The configurations that we made on the switch are making some ports access ports and some ports trunk ports to the router, configuring a default gateway, creating VLANs, and assigning switch ports to the VLANs. Now, how did we create these VLANs? Assuming there are 4 floors, we assume there are 4 floors per campus, each of which will be on a separate VLAN. In all, we need to create 4 VLANs. To create a VLAN on the switch, we're going to use the following command, which is enter the configuration mode and enter VLAN and the VLAN ID. So here we are assigning an ID to the VLAN. Then we can also go ahead and name the VLAN to be able to easily identify it. So in this example, I'm using WITB1. Next, assign switch ports to the VLAN. Now the VLANs that have been created are now active, but they don't have switch ports associated with them. This makes the switch still just a single broadcast domain. So to assign switch ports to the VLANs, the following commands are used. We're going to enter into the configuration mode, then enter the interface type and the interface identifier. Now the interface type in this command can be gigabit Ethernet or a fast Ethernet port, and the interface identifier can be 0/1 or 0/2 and so on. Then we can also add in the second command, we are assigning the VLAN ID, that is the ID of the VLAN the port is to be part of. So we can assign port 2 and port 3 to a particular campus or a particular floor in the campus. Next, we're going to be looking at configuring the default gateway. Now the switches in the department need to have a gateway for packets that are destined outside the network or the VLAN, and this can be configured using the command below. We pass the IP default gateway and the IP address. So where the IP address in this command is the IP address for the interface connecting the VLAN to the router. Then lastly, we have our router configuration. The router is the most powerful network device, and for it to perform its functions on the network, the configurations to be made are inter-VLAN routing, network address translation, create sub-interfaces for each VLAN on the core switch. Now more of this will be explained in the demo, which I'll be showing now. Some of the configurations that were set and protocols that were followed while designing the network for Ontario Tech University. Let me try and zoom in now. Now we can see the 3 campuses. We have North Oshawa campus, Downtown Oshawa campus, and Whitby campus. The North Oshawa campus is going to be acting as the main campus, and it's going to be hosting the data center and the DMZ. And now the data center, now this covers for the 3 campuses. The data center has the internal applications that is only supposed to be accessible by those within the campus, and that's server 2, 3, and 4, and we have the server 0 and 1, which is across the DMZ. This is for just host the public applications that is supposed to be accessed by those outside the campus. This is a security measure to prevent external parties from accessing internal applications. Now if you look at each campus, they are set up in a local area network. They are all set up in a local area network that comes together to form the campus area network. They follow the 3-layer hierarchical model, which has the access layer, the distribution layer, and the core layer. Same for the downtown campus, access layer, distribution layer, and the core layer. Same with the Whitby campus as well. Now let's start with the access layer. Now the access layer has the access port, which is connected to the end devices, and the trunk port, which is connected to the distribution layer switch. Now the access port only allows traffic from specified VLAN. So if you look at this switch 2, it has only allows VLAN 10, this only allows VLAN 20, and this only allows VLAN 30. Now this is also a security measure to prevent a certain broadcast from just broadcasting to every body within that network. Now this is compared to the trunk port that allows every traffic to come in from different VLANs that are appended to it. The access port only allows traffic from VLANs of specified VLANs. Now we can check the VLANs that are accepted at the trunk port by simply enable this, then show VLAN brief. Now you can see the 4 VLANs are selected as VLAN 10, 20, 30, and 40. Now at the if you notice at the distribution layer, we have 2 switches. This is for redundancy purposes, and to reduce the work on the multi-layer switch. Now if one of these goes down, one is able to pick up and continue in the communication process. And also, if you notice, there are 2 connections between the access layer and the distribution layer. Physically there are 2 connections, but logically there's just one connection that is bundled into one. We can check that connection by simply running a command. So enter this and show data channel summary. Yeah, so this is port 3. If you look at port 3, we have 2 connections, which is FA01 and FA02, and this is basically just 2 connections that are bundled into one. This is to increase throughput. So instead of say data going through at a speed of 100 Mbps, 2 connections will increase that to 200 Mbps, which is increasing the throughput as well. Up to the multi-layer switch. The multi-layer switch is a layer 3 switch and is also responsible for routing and also responsible for the dynamic IP addressing. So instead of using a DHCP server for dynamic IP addressing, the multi-layer switch can do that as well. Now onto the router. The router is here we set up a NATing process where so no one has a NATing process basically. So devices that send out information here from their private IP pick up the IP of the router and send out to external parties. So they have no access to the private IPs of these devices here, of the devices within the school campus. They all make use of the public IP of the router. Now it also keeps track of the port address. It does a port address translation, and the router keeps a table within it that keeps record of every translation to know where to route the traffic to. Now we can check that, but first we need to ping one of these devices. So let's say server 3. The IP address is 10.10.44. So I'll be pinging from one of the devices here. So first it has an IP. Sorry. So ping 10.10.44. So we got a reply from there. Alright. So now we can check the NAT table on the router. So this is on downtown campus. So here we enable, and we show the IP NAT translation. So this is the source and this is the destination. Now this is the IP of this 192.168.10.8 is the IP of the device we sent the ping from, and the destination was 10.10.40.4. So it goes out as the public IP and it goes to the destination, which is 10.10.40.4. That's server 3 on this end. Yeah, so that's basically how you keep track of the destination or how to route traffic and know where to come back to. So up next we have the firewall. So the firewall keeps hold of there's a access control list that is done here because of its connection to the internet. This internet is what allows external or public parties to access the DMZ. Now we can check the rules that have been set on this access control list by basically saying, let's exit here first. this, we don't set any password, then show run, so we can show the running configurations here. These are basically all the configurations that have been set for the firewall. Okay, so it has the static routing. Static routing, yeah, has static routing that has been set to tell the firewall where to send a particular traffic to, and it has the access list that basically shows what traffic is permitted. So from the DMZ, any traffic is permitted. This is as I said, the DMZ is what allows public people not within the campus to access server 0 and 1. Then we have to access any of this is any as well, any, to, and so on and so forth, as I stated here. And we have the OSPF that we use for dynamic routing, yeah, dynamic routing with OSPF. So this is basically to dynamically broadcast the routes to neighboring devices. So instead of going from one network to another network, setting up static routes, this OSPF will broadcast the route of a particular network to the neighboring ones, and they go on like that. So that's basically the brief overview of configurations that we've set up while working on this network. Now I'm going to be so that's the demo now. So back to the presentation. In conclusion, this presentation, a network has been designed for 3 campuses in Ontario Tech University, with principles such as VLANs in multiple area networks using Cisco Packet Tracer. The VLANs have been used to logically group clients on the network with the aid of router and transfer setups. Data packets have been routed from one system to another, which was kind of the goal of this project, to make networks to be able to communicate and route data from one place to another. Also, we can note that in the future, this network can be further developed and additional functionality can be added to increase support and coverage. Now, these are our references, and thank you for listening. Any questions?